Dear students and my dear friends, today in this session of Production and Industrial Engineering, we are going to discuss the topic from the subject of tool engineering. So, which is an important subject for production and industrial engineering students. So, the various topics we are going to discuss today are related to principle of locations. So, I hope all of you will understand and enjoy this discussion. So, let us start with the first topic. So, if we discuss about the rationale of this subject, that is why this subject is important for production and industrial engineering students, the diploma holders studying this course are required to supervise and work in tool rooms, tool design sections and production shops in the industry. So, they are supposed to have knowledge about the cutting tools, jigs and fixtures, principles of location, press tools and modules for plastic processing. So, this subject aims at development of skills in design and drawing of various types of jigs, fixtures and press tools and dies for plastic processing. Next topic is locating. So, what is locating? The question of properly locating, supporting and clamping the work is important since the overall accuracy is dependent primarily on the accuracy with which the workpiece is consistently located within the jigs or fixture. So, there must be no movement of the work during the machining. Locating refers to the establishment of a proper relationship between the workpiece and the jigs or fixture. The functions of clamping is to exert a force to press the workpiece against the locating surfaces and hold it there against the action of cutting forces. So, basic principles of location. Locating and clamping are critical functions of any work holders. To perform properly, work holders must accurately and consistently position the workpiece relative to the cutting tools, part after part. To accomplish this, the locators must ensure that the workpiece is properly referenced and the process is repeatable. Referencing and repeatability. So, referencing is a dual process of positioning the workpiece relative to the work holders and the work holder relative to the cutting tools. So, referencing the work holder to the cutting tool is performed by the guiding or setting devices. So, with drill jigs, referencing is accomplished using drill bushings. So, with fixtures, referencing is accomplished during by using fixture keys, filler gauges and or probes. So, referencing the workpiece to the work holder on the other hand is done with the locators. So, if a part is incorrectly placed in a work holder, the proper location of the workpiece is not achieved and the part will be machined incorrectly. So, to avoid all this, likewise, if a cutter is improperly positioned relative to the fixture, the machine dial is also improperly located. So, in the design of a work holder, referencing of both the workpiece and the cutter must be considered and simultaneously maintained. So, repeatability is the ability of work holder to consistently produce parts within tolerance limits and is directly related to the referencing capability of the tool and of the tool of the cutter must be consistent if the jigs or fixture is to be maintained desired repeatability. The work holder must be designed to accommodate the workpiece locating surfaces. The dial locating points on a workpiece is a machined surface. Machined surface permits location from a consistent reference point. For example, cast, forged, sheared or shaped surfaces can vary greatly from part to part and will affect the accuracy of the location. The mechanics of locating. A workpiece free in space can move in infinite number of directions. For analysis, this motion can be broken down into 12 directional moments, or we can say 12 degree of freedom. All 12 degree of freedom must be restricted to ensure proper referencing of a workpiece. So, here in this figure we can see the 12 degree of freedom. So, as shown in this figure, the 12 degree of freedom all relate to the central axis of the workpiece. So, notice the 6 axial degree of freedom and 6 radial degree of freedom. The axial degree of freedom permits straight line movement in both directions along the 3 principal axes shown as x, y and z. So, here we can show this is x axis, this is y axis and this is z axis. The radial degree of freedom permits rotational moments. Here we can say that this is are the rotational moments along x, y and z axis in both clockwise and counterclockwise radial directions around the same 3 axes. The devices that restricts a workpiece movement are the locators. The locators therefore must be strong enough to maintain the position of the workpiece and to restrict the cutting forces. So, this fact also points out a crucial element in work holder design, that is, locators, not clamps, must hold the workpiece against the cutting forces. Locators provide a positive stop for workpiece placed against the stop. The workpiece cannot move. Clamps, on the other hand, rely only upon the friction between the clamp and the clamped surface to hold the workpiece. Sufficient forces could move the workpiece. Clamps are only intended to hold the workpiece against the locators. Forms of locations. So, there are general 3 forms of locations. Number 1 is plane, number 2 is concentric and number 3 is radial. So, plane locators locate a workpiece from any surface. The surface may be flat, curved or have an irregular contour. In most applications, plane locating devices locate a part by its external surface. For example, as we see in figure 2a. So, figure 2a shows the plane locator. Similarly, figure 2b which is the concentric locator. For the most part, locate a workpiece from a central axis. This axis may or may not be in the center of the workpiece. The most common type of concentric location is a locating pin placed in a hole. Here we can see that this is a locating pin placed in a hole. Some workpieces, however, might have a cylindrical projection that requires a locating hole in the fixture. So, as shown in this figure 2b, the third type of location is the radial location, which is shown in the figure 2c. These radial locator restrict the movement of a workpiece around a concentric locator. So, in many cases, locating is performed by a combination of the three locational methods. Locating from external surfaces. So, flat surfaces are common workpieces features used for locations. So, locating from a flat surface is a form of plane location. Supports are the principal devices used for this locations. The three major forms of supports are solid, adjustable and equalizing as shown in next figure. So, here in this figure we can see that solid, adjustable and equalizing supports locate a workpiece from a flat surface. So, in solid case, solid supports are fixed high locators. They precisely locate a surface in one axis. Though solid supports may be machined directly into a tool body, a more economical method is using installed supports such as rest buttons. Similarly, the adjustable supports are variable high locators. So, in this figure we can see this is the adjustable supports given in this diagram. So, like solid supports, they will also precisely locate a surface in one axis. So, these supports are used where workpiece variations require adjustable supports to suit different heights. So, these supports are used mainly for cast or forged workpieces that have uneven or irregular mounting surfaces. Similarly, in equalizing supports, this figure shows the equalizing support. These are a form of adjustable supports used when a compensating support is required. Although these supports can be fixed or positioned, in most cases equalizing supports float the accommodate workpiece variations. As one side of the equalizing support is depressed, the other side raises the same amount of maintain part contact. So, in most cases adjustable and equalizing supports are used along with the solid supports as shown in top figures. So, locating a workpiece from its external edge is the most common locating method. The button or primary locating surface is positioned on three supports based on the geometrical principle that 3 points are needed to fully define a plane. Two adjacent edges, usually perpendicular to each other, are then used to complete the location. The most common way to locate a workpiece from its external profile is the 3 to 1 or 6 point location method. With this method, 6 individual locations reference the restrict the workpiece. In this figure 4, 3 spots on the primary locating surface restricts the 5 degree of freedom. So, here we can see that these are the primary locating surface and these are the 3 spots given, and this is the top view of this figure. You can see that these are the 3 spots given to this primary locating surface. So, how we can restrict the 5 degree of freedom? So, as shown in this figure, 3 locators or spots are placed under the workpiece, as we can see in this diagram. So, these 3 locators are usually positioned on the primary locating surface. This restricts axial moments downward along the z axis, that is 6 axial location, and radially about the x axis 2 location, that is 7 and 8, and upon the radially y axis, that is 9 and 10. Together the 3 locators restricts 5 degree of freedom. So, here in this figure, by adding 2 more locators on a side restricts total 8 degree of freedom. So, here we can see in this figure, these are the additional 2 locators placed with already having 3 locators. These 2 locators are normally placed on the secondary locating surfaces as shown in this figure. So, they restrict an additional 3 degree of freedom by arresting the axial moments, that is plus y axis, and the radial moments about z axis. These two moments are 11 and 12 moments. Similarly, in this figure, adding a final locator to another side restricts 9 degree of freedom, which completing the 3 to 1 location process. So, these are the 3 locators already we have placed inside this work, and these are the 2 locators we have placed already the side of the work, and this is the additional locator placed which completes this 3 to 1 location process. So, in this, the final locator as shown in this figure is positioned at the end of the part. It restricts the axial moment on one direction along the minus x axis. Together, these 6 locators restricts a total of 9 degree of freedom. So, the remaining 3 degree of freedom, that is number 1, 4 and 5, will be restricted by the clamps. Although cylindrical rest buttons are the most common way of locating a workpiece from its external profile, so there are also other devices used for this purpose. So, these devices include fast slide locators, V locators, nest locators and adjustable locators. Locating from internal surfaces. So, locating a workpiece from an internal diameter is the most efficient form of location. The primary features used for this form of location are individual holes or hole patterns. So, depending on the placement of the locators, either concentric, radial or both concentric and radial locators are accomplished when locating an internal diameter. So, plane location is also provided by the plate used to mount the locators. The two forms of locators used for internal locations are locating pins and locating plugs. The only difference between these locators is their size. So, locating pins are used for smaller holes and locating plugs are used for larger holes. So, here in this figure, the two locating pins mounted on a plane restrict 11 out of 12 degree of freedom. So, as we can see in this figure, this is the concentric locator, this is the radial locator and this is the workpiece where these two locators are placed. This is the front view of this arrangement. These are the plane locators placed inside this job. So, as shown in this figure, the plate under the workpiece restricts 1 degree of freedom. Here we can see that this is the plate and this is the workpiece. It prevents any axial moment downward along the minus z axis. So, this is the downward z axis. The center pin acting in conjunction with the plate as a concentric locator prevents any axial or radial moments along the x and y axis. So, together these two locators restricts 9 degree of freedom. The final locator, the pin in the outer hole, is the radial locator. In this figure, this is the radial locator that restricts 2 degree of freedom by arresting the radial moment around the z axis. So, together the locators restricts 11 degree of freedom out of all 12 degree. So, the last degree of freedom, that is 12th degree of freedom in the plus z direction, will be restricted with the help of clamp. This is a plus z direction, upward side. So, analyzing machining force, here in this figure we can say that cutting forces in a milling operation should be directed into the solid jaw and the base of the vise. So, this is the direction of the machining force applied during this process. This is the clamping force, this is the rotating direction of this milling cutter, this is plane milling cutter. The most important factor to consider in fixture layout are the direction and magnitude of machining forces exerted during the operation. So, as shown in this figure, the milling force generated on the workpiece when properly clamped in a vise tend to push the workpiece downward and towards the solid jaw. This is the downward direction and this is the direction about the solid jaw. The clamping force of the movable jaw holds the workpiece against the solid jaw and maintain the position of the part during the cut. So, here in this figure, the primary cutting force in a drilling operation are directed both downward and radially about the axis of the drill. So, this is the workpiece, these are the clamps provided, this is the direction of clamping force applied, and this is the tool, and this is the direction of machining force applied on this work. So, another example of this cutting forces on a workpiece can be seen in the drilling operation as shown in this figure. The primary machining force tend to push the workpiece down into the work holder support. So, this is the direction downward to the work. An additional machining force acting radially around the drill axis also forces the workpiece into the locators. So, the clamp that hold this workpiece are intend only to hold the workpiece against the locators and to maintain its position during the machining cycle. So, the only real force exerted on the clamps occurs when the drill breaks through the opposite side of the workpiece. So, by clamping action of the part on the drill, the machining force acting on a correctly designed work holder actually help to hold the workpiece. So, locating guidelines, that is how can we locate a workpiece. So, no single form of location or types of locators will work for every work holders. So, to properly perform the necessary locations, each locator must be carefully planned into the design. The following are a few guidelines to observe in choosing and applying locators. So, positioning locators, the primary function of any locator which we are using during any process is to reference the workpiece and to ensure repeatability. So, unless the locators are properly positioned, however, these functions cannot be accomplished when positioning locators both relative to the work holder and to the workpiece. So, there are a few basic points to keep in mind. So, whenever practical positions the locators so they are contact the workpiece on a machined surface, the machined surface not only provides repeatability, but usually offers a more stable form of locations. So, the workpiece itself determines the area of the machined surface using for locations. So, in some instance the entire surface may be machined, in others especially with castings only selected areas are machined. The best machined surface to use for locations when available are machined holes. So, as previously noted, machined holes often the most complete locations with a minimum number of locators. The next configuration that affords adequate repeatability is two machined surfaces forming the right angle. So, these characteristics are well suited for the 6-point locational method regardless of the type of conditions of the surfaces used for location. So, however, the primary requirement in the selection of a locating surface is repeatability. So, here in this figure, locators should be spaced as far as apart as practical to compensate for slight irregularities and for a maximum stability. So, here in this